have any features. For example, Eric actually raised one yesterday saying, you know what, can I have a header-based routing from the LB, right, for our services for version 2 of containers that we have, or applications we have. There's a private beta which came up, and I said, you do a private beta, and then test it out, see how it works. So it makes life easier. Like these are the kind of things that I will escalate internally, saying that customer wants this, right? And if you have more volumes coming through, yeah, it can happen sooner than later. So those are the kind of things that I would help you guys with. And if you have any ground transaction requests, which threw me on yesterday and said, okay, can you do on Fargate? Yeah, lovely. Yeah, I can do on Fargate. No, not done before. This is my first time doing on Fargate. Give you feedback. But yeah, so this is the kind of things that I do. But if you have like, any deep dive discussions or talks you want to do, or solutions, blah blah blah, want to have coffee, talk about cool other stuff that you guys are trying to do within the office, doesn't matter. Bring it up. I'm more than interested to know what you guys are doing, what do you want to do, or what do you have in your mind to talk about. So, as requested, I'm going to talk about containers on AWS, specifically stressing on Fargate. I've added a few things in the last moment as well, just because everyone's concerned about costs. And Fargate, and every time I have this, saying, oh, Fargate, gosh, this is ECS, right? So I wanted to update that slide deck, and I did that as well. Cool. So, can I ask how many people know about containers or have worked on containers? How many people have worked on containers on AWS? Oh, okay. This is on EC2 using ECS or just containers deployed into EC2, correct? Yeah. Kubernetes. Okay, cool. Just not going to touch Kubernetes here, but I'll explain. Anyway, I'll explain what's coming in Kubernetes as well, right? Kubernetes only on EKS Fargate will be there as well by the end of the year, hopefully. But yeah, yep. I'm going to still touch on bases because most people do not know about containers. So before the evolution of containers, right? As I said, one of the organizations basically which happen to do the same stuff or provide a platform as service, right? Were having this challenge as well, and most of the organizations were having these challenges again, saying that, oh, we've got different application stacks, we've got different hardware deployment environments, and so forth. You have to manage different hardwares, different OS, different underlying application support for that, and then migrate from one environment to another as well. So yeah, QA server. Okay, we want to make sure that they all maintain, they all version. Each time we deploy, they are correct and fine. So yeah, we had some things before this, like creating pipelines, ensuring vetting, scanning across, and yes, whatever we have deployed is all standard, same standard, and then we just had a lot of development work to be done, right? So a lot of cross-checking testing to be done, which in a way is we got into a situation where saying, oh, why not just containerize that, right? Why not just take a subunit of the whole hardware rather than say, okay, we're not going to take the whole OS or whole VM or whole server around it. We just have libraries against it. Make it lightweight and portable so that we deploy the application in a containerized fashion where you have separate libraries, where you have the amount of grants that you need, which is memory and CPU for a particular application to run, and just version that and ship that wherever you want, right? It's dev, test, production, I don't care which environment it's configurable. We can do that and ship that across. So that was the invent of Dockers, and it actually came out of a problem anyways for the organization as well. So that's how Docker basically came out. So lightweight standalone executable package, whole package. So it's package software, includes all the dependencies as said, system tools, runtime, libraries as you require. and then isolates software from all the surroundings. So you can have multiple of your package application within the same ecosystem. Say example, you have a SQL server which is running MySQL inside, which is running on a container, and then you have a web application as well, which is just referring to that, all living in the same server, a large server, but having their own ecosystem, right? So they're just connected through API calls internally, request calls, references, and it just works fine. And if you want to update just the SQL server, you don't have to update the whole server from there, or you do not have to deploy a new version of any or instance type. So you're saying, oh, I want to change that. Just deploy the containers with a different version. And that's the beauty. You can test with multiple versions within the same instance types or within the same environment as well. Like having dev environment and having 3 different versions of your containers and testing that out. So, yep. What happened? It's okay. Most of the people, when you talk about containers, like Docker, obviously, and we support Docker as such. It's licensed in Apache. It's again, it's the denomination now with containers. We say it's normally Dockers. We talk about, and we on our services we do support Docker, and that's how Docker Engine normally works, right? Just giving a gist for people who are not aware. Not aware. Cool. So usually you would have a registry where you would build your application package. You would build, okay, what are the packages would I require to build, say, Nginx or any other thing that you want specifically. It's MySQL, SQL Server, what do you want to pack into a chunk of configuration. I don't like this.
It's not your problem.
No, but yeah, it's just flaky.
That's no.
And then you,
This room.
yeah. And then you actually put that into a registry. Just imagine that this is a storage location where the application, like Docker host or ECS in our case, would refer from and pull that down and basically build or build that container across within the instance. So cool. So Docker Daemon will actually reach out and you can pull that across, pull the image. And then run that across into the containers, build the containers out of it, and then you can have interconnectivity between them through what you call as let's go. Next one. Go into image, base image. You can mix match of them. I'll just keep this. So yeah, what you can do is basically build and create a task definition of it, saying that okay, I have a task definition which says okay, this image or say your Apache web server or Nginx server is basically linked to the MySQL one where you have to basically connect and interact. You give individual ports details for them, and then you connect on those ports. And the Docker container ports quite different to your actual server ports, which is the beauty where you can have different ports references for each and every container as well, and run that across in multiples of them. So ECS is our service. It's a highly scalable performance container management service. Its evolution basically came across saying, oh, you know what? There's a lot of containers, a lot of containerization, which a lot of organizations do. Does EC2 support? Yeah, why not? Bring on your Docker container and build that across on each instance, and you do all the management stuff. And then customers just said, okay, I don't want to do the management stuff. I just want to deploy my containers, right? Can you have an overarching layer where you can build a cluster? Let AWS provide us a service to build that cluster, to build the instances behind the cluster, manage that within auto scaling within the same pan of service. And that's how ECS came through. which has evolved further with the management layer of Fargate, which I'm going to explain later on. So this is what an ECS objects look like. So you have a container definition, which specifically talks about what's the CPU memory you require on a particular task that you want to run. Then you have a task definition, which includes all the details of what images you want to pull down, what are the links between each other, what the port numbers they're going to run on, and service, which is basically comprising an overarching layer itself on the whole task, which interacts with the ALB and has its own service events. You can basically see what's happening with the service and have the tasks within running, tasks which are running within the service. What are they doing? All those are done at service. You can actually see when you actually launch the ECS cluster, the service actually interacts a lot with the ELB or external interface or ALB if you create one. And cluster management is basically having a layer of running backend EC2 instances on a number of tasks in the services itself. This you probably would not know when I probably show the console and say, this is a cluster, this is a service, this is a task definition, and so forth. Let's give you much more construct on that. So that's how it is. You have a task definition, which is registered, put into an image, which has the image URL, CPU, memory, as I said before. And then you have the task, which basically instantiation of the task definition. Literally, it's just a copy of your task definition, which is actually executed. That's it. Services, which contains multiple copies of this task, integrate to the ELB. If any unhealthy tasks are there, which say probably not responding, and you're checking, this web server is not actually responding back. So what's happening? So that task would be marked as unhealthy. Another task would be created.
Is it actually rules ELB or ALB? Yes,
So
ELB.
So ELB has three categories. So when we did not have ALB and NLB, network load balancer, we actually called it as ELB and still known as ELB. So now it's categorized as the ELB is called as classic load balancer, and then ALB, application load balancer, and NLB, right? But it is in the family of ELB. Cool. So what's the benefits of ECS that we have? Okay, you have different types of networking mode, which I'll highlight a little bit as well. What kind of different networking modes are there? Obviously, it's auto-scaled within the same ECS domain. You have load balancers, scheduling engines to schedule the task when the task is going to be. So if you're seeing that, okay, in the morning times, we have a lot of customers coming in and doing payment stuff or requesting for it, you can launch a number of tasks, and by evening probably just go down, having like the operational number of tasks that you want to run. And you can have placements as well, task placements to run through. So you can group them into, say, a number of instances and loop them into a placement group itself. So, yeah. So this is what it looks like on ECS, right? Or traditional ECS that we have. So you got an EC2 instance, right? You launch in say M4 large instance type, and then you have your tasks running in it. But to run that task, normally you have an ECS agent in this world where it basically interacts with the control plane, the ECS control plane, and say, okay, what do you have a task definition to run? Do you have a task to remove or delete? It's basically that interface which does all the stuff, right? You have ECS AME. When I say ECS AME, either it can be an AWS provider, ECS optimized AME, or you create your own AME version and basically run that on basically installing the ECS agent and Docker agent. You can attach to an ECS cluster and run that. So you manage that completely in terms of that AME as well. Docker agent, obviously, you have to pull down and update that. Finally died.
Yeah.
It died, really? So the challenge over here, I don't know. Can someone say what's the challenge over here?
Managing both containers and instances.
Okay,
Scaling.
as a developer, who's a core developers over here, or everyone's developer anyways, but like someone might be operations, someone might be just so all developers. What are the thing that you want to touch over here? Literally, what is your focus as a developer?
Okay.
Your tasks, right? Which is what you want to run. So that's a challenge where say, okay, if I have my own version of instance type or image, right? Then basically I have to maintain that, I have to patch it, right? At the OS level, I have to patch it. I want to make sure that it is up to date, especially if it's Windows, right? And you have to keep it updated. You have to keep it rolling, right? Every month or so. We release our own IMI every month for a new Windows version. And then you have Docker agent, which you have to update, right? And then you have ECS agent, which again you have to update. Provided if you have, say, Amazon provided ECS optimized image, which also has SSM within it. I don't know if you guys know SSM. You can basically update that ECS agent just running a run command across the whole fleet. That makes life easier, but again, you have to patch, you have to basically go and update Docker agent. If there is a problem with Docker agent, you have to go and diagnose and find out what's the issue and blah blah blah. Which is what you do not want to do. And customers ask us, like, you know what, all this orchestration layer, I don't want to know. I just want to run my task. That's what Fargate does for you, right? So obviously you have a number of instances that you're going to choose. Let's choose M4X large. Okay, what's the CPU? What's the memory? And how many tasks we can run in that, right? So you basically continuously are trying to do a right sizing procedure saying, on this instance, how much we can get out of this instance, how much we can utilize as an instance. And then if you're running, say, an M5, M4X large, I'm just saying it has like 16 gigabytes of RAM and then 4 vCPUs, and you're just using one vCPU and like 2 GBs of RAM, I'm going to come back saying, hey, you know what, you're underutilizing an instance type. What's happening over here? And then the whole exercise, let's benchmark, right? And then use the instance type as we can. So keeping that aside, the whole exercise of patching, whole exercise of updating, whole exercise of maintaining the cluster, someone sitting like, let me build the whole confirmation stack and actually build that up in terms of building the cluster, ensuring that we change the instance type based on the parameters, whatever we require, and so forth and so forth. So you do not have to do that anymore with Fargate. That's what Fargate provides you. Fargate basically says, okay, what do you require as a container? What do you want as part of your task when you run? CPU, memory. That's about it. Nothing more than that. So the whole billing model around Fargate is just CPU and memory that you use. And the model is on per second basis as well, with a minimum of 1 minute. So if you run a task, say, for 1 minute 10 seconds, you'll be charged for 1 minute 10 seconds, right? Whereas if you have an instance, if you're running for an hour, or even 10 minutes or 30 minutes, you'll be charged for an hour. We do have instance types for per second billing as well, but per minute billing as well. But yeah, this goes further granular with per second. So it's good if you calculate and actually see what's the total cost of managing all the things that I mentioned before with ECS and picking up just Fargate. Let's just make life easier. So what's Fargate as such, right? There's no instance to manage, as I mentioned. It's just Task Native API. It basically is sitting on ECS, and it supports all ECS APIs, right? The way you choose when you actually go into ECS console, you say, okay, do I use the platform as EC2 instance or Fargate? And now it's generally default as Fargate. If you see the console, it'll come as Fargate. You can choose as EC2 instance as well to create a cluster. But
It supports all native ECS API calls that you require. CLI, if you have any calls, it will support all of them. And it's, as I said, it's resource-based pricing. It's not on saying, oh, I've got an EC2 instance, but I'm running only for 10 minutes or 20 minutes, and or probably 40 minutes, back 20 minutes, we just keep it aside, so forth. So it's, if you do it right, you can save a lot on that. There are different permission tiers over here as well. So this is something that you might know about it already, but these are not actual like tiers. It's just a abbreviation of saying what it does. So cluster permission, it's predominantly to manage across the whole cluster. And say cluster instance, cluster management. What are the number of tasks you want to run? What are the services and so forth? That's where it comes through. Application permission, it's specifically to the containers. Like a particular container, what access it requires within the AWS ecosystem, what API calls you are going to provide to that container, saying, okay, you have the permissions to run, say, access S3 bucket or ECR or something else. That is the level of application permission we're talking about. And then you have like tasks, housekeeping permissions to say, pull the image, ENI creation, and CloudWatch pushing. So you have logs which you want to push across to CloudWatch. This is what it does. Any registration with your ELB, which includes classical browser and ELB, it'll basically do those tasks. These are set of permissions you require to give while you're building this up. So it's, you have different layers of permissions that you can provide. Okay, it's not just like, oh, just give an iron rule and does everything for you. So it's good. So what's the difference between Fargate and ECS? I had quite a few questions about 30 minutes of discussion yesterday with the team, and I had the same question like, oh, why Fargate? Why ECS? Why Fargate over ECS? Or why ECS over Fargate? So there are different modes which are supported in ECS itself. Bridge mode, host mode, AWS VPC, and none. Basically, it's like no modes at all, just default always. Bridge mode is basically saying that if you want to interact with the same ENI which is attached to a task, and you want to share that across multiple of your other tasks. So that's how the bridge mode goes. It's worse in a sharing mode, right? All the interconnectivity between the other containers are routed through that particular ENI. Host, obviously, it basically picks the underlying hosts, say port number, port or ENI itself, right? So if you have specific port that you have for the host itself, like for 80 or 8080, it'll just take that one. So there are use cases where you have people doing that. And then you have AWS VPC one, which basically attaches ENI per task. And that basically gives you the ability to isolate that particular task for any interaction with other API, other services. Say this particular task you want to interact with, say S3 or RDS, you can basically isolate that task itself with say security groups, rules, and so forth. So you can actually attach that to an ENI. Say, okay, this is what you want to do, right? At a security level, it just helps much more. I mean, ECS provides it. Fargate only supports AWS VPC, right? What happens in background, basically, we launch a fleet of instances, which are basically sitting. Some of them are pre-bombed, and they're waiting. Some of them are in the queue, and as the demand comes in, and we say, okay, yep, the threshold is reached to 50%, we'll launch a few more instances to be ready. We are frugal, so we make sure that we are running only the optimal amount of instances which are required in the backend as well. And we create a set of ENIs, a bunch of ENIs within that construct as well. So it just makes life easier to actually share that across and attach as quickly as possible. So if any problems happen with this, where you have an ENI, you'll have to go and diagnose or raise a sport casing.
have a problem with an attached to this particular container. How do I fix it now?
And you have to go and actually like troubleshoot along with the support team and fix that up. With Fargate, it is done underneath, so all management stuff for that. So if anything goes wrong, it'll be reattached as well. A new init will be created to be reattached, and so forth. As I said, billing model is per second. We're going to talk about the billing in a few minutes. And then storage. Now in ECS, basically you have instance storage. So if you have an EBS package EC2 instance type, then obviously you have that EC2 instance type. If you have ephemeral based storage on an instance type, you use that. Additionally, you can add additional storage volumes as well within ECS cluster. On the backend on the instances which are running within the cluster. But Fargate, it has a 10 GB layer of storage per task attached to it. This is by default, right? This storage is ephemeral. So if you turn off the task, it's gone. Which is what you should not be doing anyways in ECS as well. So you should not be storing anything within the containers itself if it's something that you want to persist. And then you have, for persistent storage, you still have like 4 gigabytes of volume space per task. That's by default, you can actually attach that to a target task.
Sorry,
You
so
can-
10 GB is ephemeral or 4 GB?
Now, 4 GB is EBS, so this is basically persistent storage. You can add more. It's not there. It's just Fargate by default says, okay, I'm at this moment, I can provide you 4 gigabytes of persistent storage. You can attach that to per task, and you have 10 GB layer storage. When I say layer storage, basically storage attached to a task. If it's unutilized, I think the other tasks can utilize it. How is it? I don't recall now. Yeah. It's a layered storage where I think you can utilize, if it's underutilized within the target cluster, it'll basically share that across, but isolate it across only within the block, saying this task, this is the block that you're using, but it'll just share that across. That's what I don't know. I'll probably dig in further on that and find out. But yeah, you can attach EBS volumes or EFS storage you want to have. You can still attach it to a task. That's still there. That's one of them. As part of the management, as I said, you just focus on task and figure out the rest of the things in terms of patch management, AMI version, Docker and ECS agent updates. You don't have to do that. It's all good with Fargate on that sense. So pricing. I was writing this while it came across, and I was actually typing that we do not have a apple to apple difference. We won't do with our services anyways, but most of the people ask, can I have like an example of how would it cost, right? So this is what it does. Like if we charge based on vCPU and memories, right, on Fargate. And if you say, if we take an example of M4 large instance type, and we say we're running only one task within that, an M4 large instance type has 2 vCPUs and 8 GB memory. So I literally took the same example, saying why not take apple to apples, try and compare it. And if you run one task on this, right, utilizing two vCPUs and 8 GB of memory, completely on this instance on an ECS cluster, it will cost us in Sydney region about $90 per month, right? Just trying 24/7, 30 days. Cool. But if you run the same thing in Fargate with 2 vCPUs, 8 GB memory, this is how it's calculated, saying, okay, one task, 2 vCPUs, what's the cost of that per hour? Because it's per second, but in the billing console, if you in the billing AWS billings, if you go, you will see, okay, it's per hour. You can divide that into per second as well, but charging is per second. Just for making our life easier, it's mentioned as per hour, and then 24 hours, 30 days, right? So that's $69 and about $30 for vCPUs and memory. It's about $99, right? It's pretty close. Plus, you don't have to do any management stuff.
What is the minimum amount of CPU? It's one vCPU per task in Fargate, right?
No, it's 0.25
Point
minimum. You have different combinations to use. Max, you can go to four vCPUs, about 30 gigabits of RAM. Yeah, gigabytes of RAM, sorry. But yeah, I don't know if you have any containers which are running four vCPUs, 30 gigs of
That's why
RAM.
I'm asking, because if you need to run many small tasks,
Oh, why not?
yeah, if that's
Just yeah,
great.
I,
If
I'm just
CPU is good,
I'm
then
just trying to say,
yes.
okay, let's pick some combination because I couldn't go 0.25 vCPUs for the instance type which are provided as of now,
But
right?
you can write 8 instances there, 8 containers there.
Oh yeah, yeah,
That's
absolutely,
that's what
absolutely. That's what I'm mentioning. Say, okay, you can probably run like, if you have like 1.5 vCPUs that you're using on a particular task, you can run twice in this or four times of this. Yeah. But I was just saying, okay, let's compare with one task itself, and it's pretty close that way, right? And imagine if you have multiple tasks running on multiple instances, clustering instances, it just becomes more cumbersome as well to manage that. Cool. So we're quickly talking about ECR. This is our container registry. We do support Docker's registry itself, and something in pipeline to support private registries as well. I don't have further details on it, but yes, it's in pipeline. ECR is our own registry, container registry service. It is backed by backed by S3. It has an URL that can be accessed through directly and pulled out images from our repository. So yeah, it has all the things in terms of construct of security, like resource-based policies, cloud trail logs to find out okay who has used this registry or not, how it is used, when it was used, when it was pulled down, which containers which was pulled down. If you have the ECS agent logging all of that in Fargate, you probably have that all details as well within CloudWatch to find out when it was pulled down and so forth. Cool. As I said, we do support Docker Hub, and ECR is our own registry services. So that's the whole landscape of containers within AWS as of now, right? We have Kubernetes as well. There are a few things which are coming in pipeline, like Kubernetes. I was in Melbourne office and somebody said, "Oh, you know what? It would be good if we have monitoring of the Kubernetes control plane as well, right? We have all those monitorings within CloudWatch and find out what's happening with the Kubernetes itself. That's coming in Q2, yeah, or early Q2 sometime. And I provide that feedback to the service team saying, you know what, this is the feedback from the customer. What are we going to do about it? And say, hey, we're going to release in Q2. Be ready for it. So,
In terms of, okay, so I see that Kubernetes and ECS are sort of the same service in different offerings. What is the other offerings from competitors in terms of Fargate? Are there any?
do not know.
Kubernetes.
Yeah,
I know, this is
But-
Fargate
yeah,
as
but-
management layer he's talking about.
Because if I'm reading that correctly, right, it's saying that Kubernetes and ECS are on the orchestration management side of the containers, whereas Fargate just decides where to throw your containers, looking for free hardware somewhere.
But Fargate is more of
So let's
the-
for containers.
yeah, for infrastructure specifically for the containers, right? So EC2 again, it's a mechanism to actually run that as before Fargate, where you have more around Kubernetes on EC2. But on Fargate, basically to take off that whole management layer. And when I say management, when it just says management of the containers. It doesn't mean the management of your underlying resources, right? So it's not talking about these two. So ECS combines this together. So it has ECS API calls to say maintain the cluster, and then you'll just make EC2 API calls to say, I want to scale, or run APSG's API calls to say, I want to scale, I want to scale, so forth. So they all run in tandem, and that's how they've been built. We do build our own optimized AMI version, which means it's tested. It's proven tested across for particular service like ECS and just run across on that. So we have Windows based and Linux based, and test that out. So you don't have to say, oh, is it secure? Is it tested? Is it optimized? So,
Speaking about Windows, it was in beta last time we checked. ECS for Windows was in beta. Is it actually in GA right now?
I think we do support ECS.
You do support Windows with ECS, but is it in GA? Because it was in beta for like months and months, and I'm not sure that it's GA or not.
No, I'm pretty sure. I can see that quickly. I can find that out quickly. I've played pretty much on Linux.
We should move to Linux. We are. I'm just still wondering whether they managed to GA that or not.
So what application are we talking about? Like what tasks we talking about? What containers we talking about? Is it still
All .NET Core
Okay.
4.6?
Yeah. I've got a customer. He had a .NET Core 2 application which was running on Linux, so it's fine. It's not. There's no challenges such specific.
May I ask you
Go ahead.
about the network throughput? You mentioned about the CPU and memory in party, but how about network throughput? Because it's easy to understand. You know the throughput of the instances.
Yeah.
that you provided.
I do not know specifically. You can tune that. You said you can choose.
But even
like
at
an
least
EMI.
do you know the throughput of the tasks, or you don't? Because it might depend on the instance type, on the underlying instance type that
Correct.
you guys use.
Correct. And I understand what your point is. They're saying, okay, you know what? We want a larger. This is highly IO intensive task operations that you have, and you require which supports those kind of interactions. But I believe most of our ANIs are supporting like 25 units second of interaction. So that should be more than enough for any interconnection task or public facing one as well. So if you have like ELB and requesting into the task, it should be good.
But if it's I mean, if you go to the description of these two instances, you will see that it says that network throughput up to 10 GB, or it says high, medium, whatever.
Yeah. I did not have an answer to that as of now. Okay, I don't have like saying, oh, this is the bare minimum ENI or
No, that's fair.
yeah, and I'll try and find out. It's a good question. Cool. Any other question you guys have? If no, then I'll launch an ECS Fargate cluster in front of you guys with this blinking screen, and we'll see what happens, right? Okay, let's see this. So yeah, if you did not had containers ever launched in the account, but it's there. It will ask you, okay, you know what? Let's get started, and it has its own set of instructions that you can run. This is one run wizard. You can basically use that and launch that. So here's the container definition. This is on Fargate, okay? By default, as I said, they have changed that, and now when you do say get started or something like that, even while you're creating a cluster, by default it shows up on Fargate now. Okay, and we'll see when we create a cluster out of bound as well. So when you create a sample app, which is basically a web page, and basically showing that, you know what, successfully you have created a web page on ECS Fargate. This is your task container definition where you mention what it is, what memory, what is the CPU, correct? And further on, you have task definition. Choose your task definition. This is by default, it already has one. It's going to pull down from into S3 bucket and get the definition in. It has image which is stored across. And yeah, network mode, you can't choose that. As I mentioned, it's Amazon AWS VPC. It's going to create a new task execution role. This is what you would have to do even when you create a normal ECS or ECS with target. You need to have an execution role, what requires for that cluster and the task which you're running on that. Saying, does it require specifically to make EC2 API calls or S3 API calls? Or what does it require, right? So those kind of execution roles, you need to provide that. In this compatibility is Fargate as of now, and I'm going to just go next and say load balancer. I'm not going to attach a load balancer as of now, and say, okay, let's go ahead. What's the name? Will be demo. Let's do that. So this is the whole task definition, which says, okay, this is an Apache Web Server 2.4 sample app, which web page, which is there. It's running on port 80 on the task itself. What's the protocol? What's the memory required? And when I say memory, when you say 512 or 0.2.5 of vCPU, that's your maximum in the task. You can't go beyond it. If you want more, task will just your application will just die. It's just going to overrun itself, right? So that's where you need to benchmark your application at the exact level that you want. The way I suggest, and I was suggesting to Eric as well, saying that test it for peak and say this is the peak where if you have a lot of influx of requests coming, or we have a lot of batch jobs which are like required to be executed, what is the threshold we will require, right? What is the maximum vCPU? What's the maximum memory we would require? And that's where you choose. And obviously, the Fargate is much more. It's much more important when you have horizontal scaling. So even if you have 0.5 of these CPUs, you can scale out immediately with number of tasks and work easily with that. What I liked about this is actually they show an interface now, at least on this, right? Which was not, which is kind of there in ECS, but it was more to do with like go ahead and see in the CloudFormation stack. It's running a CloudFormation stack behind. Okay? The way to run with ECS, I would say always run on CloudFormation stack. Always. And this makes your life much easier. So you can update your task definition through parameters and say, okay, I want to change this to say another task definition version. Right? Should be okay. Run that as an update. All good.
Does it manage your bytes properly? Because we don't use CloudFormation for that. We use another scripts to allow new versions of the task definitions.
Yeah. Again, if you do, is that like an API or a CLI
sometimes
call?
CLI call.
Yeah.
Sometimes it's a bit scary to run CloudFormation because you might mix up the actual updating of the application and infrastructure updates, and you never know how it's going to behave behind the scene.
Well, if all of them are versioned, you should not be worried about it. So if you say, I know this is approved, this is tested, this is going into development pipeline, and it's in your repository saying, okay, this is certified now, that I'm happy to push in dev. You have all the version, your task definition, you have the application image as well, what you want to pull, right?
So you say that if I want to deploy a new version of the application and then change in the CloudFormation, I change the version of the Docker tag basically.
Yeah, the task
It
definition.
will create a new task definition revision behind the scene.
So you can do that update as well, so that'd be good. So it's basically created the whole thing. So you can see it has created two subnet across two AZs. So it just makes more resilient. You have a security group which basically ensure that you have an HTTP based access coming inbound, because we are basically creating a web server over here. The task definition, which we're going to look at, hopefully. Sorry, log group this task definition. And if I go and view the service itself, this is how it looks like. This is if you create a cluster by yourself with an EC2 instance, it's pretty much going to look like that, except that you'll have instances over here saying, okay, I have my cluster instances which I am managing as such, right? Cool. If I go task, if I click on the task itself, so you can see, normally you will have a private IP. You can or cannot have, like you choose, you can have public IP or not. This, by default in the wizard, they're actually giving you a public IP address, which you can use. So you have a direct access to the containers from web. But usually you would have an ELB or ALB sitting above it. So let's try this. And let me go to our browser. Let's say HTTP and see if this works, right? Yep. Okay. So it has deployed. It is successfully deployed as such with ECS Fargate. This is what your task definition looks like. Hopefully you can see an update with that. So this is how your task definition looks like. It's a little bit different to, like, I have not played extensively with Fargate, I'll be honest. I've played more with ECS. So I'm more used to saying that EC2 side of things. But yeah, you have container definition where you explicitly mention what are the port mappings you have, what are the set of, what are the entry points you have, which region it is in specifically, what's the log groups, which is going to send the logs to, the port mappings, which is host port and container ports. You have two different ports. So the request when it comes to the host, which is the auto interface, it'll basically say port 80, but for the container host, you can say port 8080 or 8081 or 900, I don't care. It'll work through. It'll just pass on that request to the container port. The number of vCPUs which are there, memory reservation, what's the image. You get all the details over here. Again, the compatibility, as I said, is EC2 or Fargate. In this case, it's Fargate that it's using. You have a specific task definition details as well over here as an ARN. So when you pick this up, you'll probably find out most of the information that you would probably want across within task definition. So this is your crux. This is your Bible for the whole container task. Right? If you pick this and modify it as you want, it should be okay. This is what I used to do. It's like, okay, give me your task definition and I'll play with it, right? I would suggest, and this is what I used to tell most of my customers, even with CloudFormation also, just don't build from scratch. Right? Yeah, if you have time, why not? But leverage on people who already built that, right? Leverage on something which is already there and just play with it, add something within that, and yeah, build your stuff. Right.
So with CloudFormation, if you update your task definition with CloudFormation and your new task definition is not going to be healthy, you deploy, but it's not becoming healthy. It's going to roll back properly.
Yeah. That's default of CloudFormation anyways. You've got
Kinda, yeah, no, because CloudFormation doesn't have container instances, right? You don't really have
Yeah,
a
you
list
have.
of instances. I don't know if it spawns depending on the number. You have
It has the auto scaling
description.
group details. So auto scaling group has to manage it. You don't, yeah. As I said, in terms of orchestration itself, you can put it into ECS itself. You can run ECS API call. That's not a problem. When you provide your task definition and everything, remember through CloudFormation as in first time, you need to ensure that you're updating through it. If
you're doing outside of it through ECS itself, that's fine. You're fine with that. It's great.
No, it's everything is through CloudFormation except of deploying in version of actual.
The image itself, you're saying?
Except of the deployment version of the task definition.
Okay.
So when we create a task definition, we pull it, we update the URL to the image
To the image?
and push it back.
Yeah,
And we control whether it's successfully deployed. If not, we roll it back. Because I mean, from other experience with CloudFormation, sometimes it's not that smart in terms of reprovisioning resources, recreating them, and sometimes
It's task, it's already has a list of what it had, because remember, CloudFormation, I don't know how many people have played with that. It keeps a tag of all the resources which it has into your DynamoDB and it just pulls the reference. It never actually deletes the resource before successfully creating another one. So as I said, the task definition would never be deleted unless until the second one was successful also. Right? As in reference, I'm not saying actual deletion, but as in reference for CloudFormation, saying that you know what it is. I was part of support before, so I could literally see the whole set of task definitions which are past history. When you run a CloudFormation stack, you can probably see what failed and so forth. I could see the whole history of the CloudFormation. So we do keep a list of references, and that's how the drift detection has come through as well. Saying that okay, you have one set of data. All we have to make an API calls to actual resource configuration and find out. I don't know, how many of you have used drift detection over here? It gives quite a few information. Sometimes it was too much. Like when I said, what's this? I didn't even knew about that these kind of configurations are there. So cool. Any questions you guys have? I would suggest just play with it. If you have a library. But if you create like a sample ECS cluster, ECS cluster with target, just burn it down quickly after that. Yeah. Cool.
Thank you.
So yeah,
I hope you guys had questions about reaching out to